Geometry students, we are going to continue our study of circles today as we study the measures of the outer edges of a circle, an arc. In this video, we're going to be talking about the angles that form at the center of circles and the arcs around the outer edges of circles. What exactly is an arc? Well, an arc is the kind of boat that Noah rode during the flood, but actually it's a different kind of arc. We're going to be dealing with an arc that's part of a circle consisting of 2 points on the circle. Okay, remember, a circle is just the outer edge, the curved figure that is all of the points a certain distance away from a center. And the arc is a part of that outer edge circle. So it's part of a circle consisting of 2 points on the circle called endpoints, and then all of the circle points in between, all points on the circle in between. We can talk about a lot of the same things with arcs that we talk about with line segments. So like an arc is like a circular line segment also. Adjacent arcs are two arcs that are side by side. They have a common endpoint, exactly one common endpoint. We could talk about a central angle, an angle whose vertex is at the center of a circle. A central angle is able to pass through the endpoints of an arc. So a central angle associated with an arc is one whose vertex is at the center of the circle, and then the rays of the angle pass through the endpoints of an arc. Then we have something called a minor arc. A minor arc is an arc that hasn't turned 18 yet. Actually, it's an arc that is smaller than half a circle. We're used to thinking of acute as less than 90 degrees. You got to be careful. Minor arcs are less than 180 degrees. The point of designating a minor arc and a major arc is that a minor arc can be measured directly with a protractor. A major arc has to be measured indirectly with a protractor. We'll talk about that in just a second. So a minor arc is an arc that's smaller than half a circle measured by measuring its central angle. That's the angle that has the center of the circle at its vertex, and then the rays pass through the endpoints at the end of the arc. A major arc is greater than half a circle, and because protractors don't extend beyond 180 degrees, you can't measure a major arc directly on a protractor. What you have to do is measure the associated minor arc that completes the circle. So if you think about it, if an arc extends past 180 degrees, it's going to be somewhere between 180 and 360 degrees. It's going to end somewhere on the other side of the circle. And what you can do is you can measure the minor arc that would complete the circle and then subtract that measure from 360 degrees. That gives you the measure of the major arc when you subtract its associated minor arc from 360 degrees. Now just kind of keep in mind the reason we're talking about that is because we have to be able to measure these things using protractors, and protractors only go up to 180. So how do you measure an angle that's greater than 180? You do it indirectly by finding the angle that completes the circle and subtracting from the whole circle. All right, a semicircle is half the circle measuring 180 degrees. And it's important to realize that a semicircle is neither a minor arc nor a major arc. It's its own special kind of arc. All right, now just some interesting tidbits to know about these. A minor arc is always going to be less than 180 degrees, but greater than 0. A major arc is greater than 180 degrees, less than 360 degrees. So just kind of keep those points in mind. And then lastly, when we talk about congruent arcs, what are we talking about? We're talking about two arcs that have the same measure, okay? We measure around the outer edge of the circle. Two arcs that have the same measure are congruent. And we say that there are two arcs that have the same measure that are in the same circle or in congruent circles, okay? So yeah, that's what congruent arcs are. Last thing I want to mention is just like we had a segment addition postulate, we have an arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So if we add two arcs together, we get the total distance of the arc formed by those two adjacent arcs together. All right, now we've got the vocabulary down. The next thing we're going to do is start working some practice problems.